Hi guys, welcome back to Technovizard. So today I'm gonna discuss the 5 most important questions of the digital. So also you can follow us on Facebook, Instagram, Telegram and the YouTube channel for the latest job notification. So now let's begin. So this is our first question. Binary 1011001 is equal to. So now in this question what we have to do is we have to convert this binary 1011001. So basically this is a binary number because this is in the form of zeros and ones, so we have to convert this binary into the decimal. So the base of decimal is 10. So how to approach this question? So the method to convert the binary into the decimal is, so we'll start from here. So this we will write in the power of 2 to the power 0. This is 2 to the power 1. This will be 2 to the power 2. This is 2 to the power 3. Okay, so this will be 2 to the power 4. This is 2 to the power 5 and this is 2 to the power 6. So now we have to find out the decimal. So 2 to the power 6 is simply 64. So this will be equal to 2 to the power 6 into 1 plus 2 to the power 5 is 32 into 0. So this will be 2 to the power 5 into 0. This will become 0. Then 2 to the power 4 into 1 plus 2 to the power 3 into 1 plus 2 to the power 2 into 0 plus 2 to the power 1 into 0 plus 2 to the power 0 into 1. So simplify this, you will get the answer. So 2 to the power 6 is 64. This is 0 plus 2 to the power 4 is 16 plus 2 to the power 3 is 8. This is 0, this is 0 and 2 to the power 0 is 1. So after the simplification we will get 89. Okay, so it means the binary equivalent of this we are getting as 89 decimal. So option A is correct. Suppose the binary is given like this. So this is 1011001. Some binary is present after the decimal. Suppose this is 0110. So how to solve this? So if the decimal is present after, so if the binary numbers are present after the decimal, so what we have to do is we will write into 2 to the power minus 1. This will be 2 to the power minus 2. This is 2 to the power minus 3. Okay, and this will be 2 to the power minus 4. So simply simplify this. So this will be 2 to the power minus 1 is, I am solving only this part because I have already solved this. So 2 to the power minus 1 is 1 by 2 into 0. This will be 1 by 2 to the power 2 into 1 plus 1 by 2 to the power 3 into 1. This will be 0. So simply this will be equal to 1 by 4 plus 1 by 8, which will be equal to, so this will be 3 by 8, which is equal to 0.375. So it means the overall answer will be 89.375. Okay, so now let's see the next question. The given figure shows a NAND gate with the input waveform A and B. Okay, so this is a NAND gate and the input waveform for the input A and B is given. So the correct output waveform for the X of the gate. So let us first write the truth table for the NAND gate. Okay, so for the NAND gate, inputs are A and B. So two inputs are there, so it means 4 combinations will be possible. This is 0 0 0 1 1 0 and 1 1. So we have to find out the output X. This is NAND, so this will be equal to A dot B bar. Okay, so this will be equal to 1 0 0 0. So this is the truth table of the NAND gate. It means NAND gate is also called as a zero detector. It means so NAND gate is one detector. If the sorry, I have written wrong. This is not the table. Okay, let just a second, let me correct. So this will be 110. Okay, sorry guys. So now what I was saying, that the NAND gate is also called as zero detector. It means if any one of the input is zero, then the output will be definitely one. Okay, so that's why the NAND gate is called as a zero detector. So now the input waveform is given. So let us draw it like here. So this is the input waveform A. Okay, I'm redrawing here. So this is our input waveform. This is A and this is input B. Okay, okay, so this is our input B. So now I'm drawing the dotted for every edge. Okay, so now I'm gonna write the zeros and one. Okay, so this is 0, this is high, so this will be 1, this is 0, this is 1, this is 0, this is 1, 0 0 1. Similarly I'm going to write for the B. This is high, so this will be 1, and this is 0, this is 1 1 1, and this is 0. So now we have to draw the output waveform X. So simply see the input. A is 0, B is 1. So see here on the truth table. So if A is 0, B is 1, the output is 1. Okay, so it means X will be 1. Okay, next is 1 1. So if 1 1 is yes, then X out of the NAND gate is 0. Then this is 1 0. So for the 1 0 it will be 1. So now detect 0. So if 0 is there, then the output will be 1. This is 0 1 is 1, 1 1 is output is 0. Okay, so 0 1, this is 1 1. Okay, so this waveform of X is matching with the option C. So option C is the correct answer. Next question is, following is a K map of a boolean function of the 5 variables p, q, r, s and x. The minimum SOP expression for the function is. So now we have to write the expression in the SOP form. So whenever SOP is there, we have to make the pairing of 1. Okay, so if SOP is there, so we will pair ones. If we have to write the expression in POS form, then we will pair the zeros. So now see here, this is a 5 variable K map. So now whenever we do pairing, first of all we give the preference for the octet. Okay, then we'll go for the quad, and if quad is not there, then we'll go for the pair, and if pair is also not there, then we'll go for the single literals. Okay, that is no pairing will be possible. So now see here, no octet is possible, so we can go for the quad. See, these are the two one and these are the two one, so they both will form a quad like this. Okay, and similarly in this also they both will form a quad. So now we have to simply write the expression. So the function will be given like so. Now while writing the expression, you have to discard the changes. Okay, so see here, so here PQ is 0 0 and this is 1 0. So it means the value of P is changing from 0 to 1, so you have to leave the P variable. Q is 0, so if 0 is there, so we'll write Q bar. Okay, and here the value of R is changing from 0 to 1, but S is 1. S is 1, so we will write S as it is 1, and X is equal to 0 for this quad. Okay, so X is 0, it means this will be X bar, then plus, because we have to write in the SOP form. So for this quad here, this is 0 1 and 1 1, so the value of P is changing from 0 to 1, and Q value is 1, so this will be Q, and here R is changing and S is 0, so this will be S bar, and X is 1, so we are getting this expression. So this is matching with the option B, so this is the correct answer. Next question is, the logic function implemented by the circuit below is ground implies a logic 0. So now basically this is a 4x1 marks. So in 4x1 marks, 4 input are there and 1 output is there. These, so for the 4 input we have the 2 select lines. So with the help of select line we select a particular input. Suppose if s1 s0 is 0 0, then i0 will be selected. If this is 0 1, then i1 is selected. If this is 1 0, i2 selected, and if s1 s0 is 1 1, then i3 will be selected. So how to solve this question? So first of all we will write the expression for the function f. So let us write in the form like this. This is m0 i0 plus m1 i1 plus m2 i2 plus m3 i3. So m0 will be selected for the 0 0, this will be selected for the 0 1, this will be selected for 1 0, and m3 will be selected for 1 1. So if this is 0 0, then this will be s1 bar s0 bar, because whenever 0 is there we put bar, and i0 is connected to, so as ground is logic 0, so this is a NOT gate, so it will invert, so 0 will become 1. And again here we have a NOT gate which is also called as an inverter, so this will invert this one input to the 0. It means the i0 input is connected to the logic 0. Then this is m1, so this is 0, so this will be s1 bar is into s0, and i1 input is connected to the logic 1, this will be s1 into s0 bar, and i2 input is also connected to the logic 1 plus this is s1 s0, and i3 is connected to the ground which is logic 0. So simply we are getting the s1 bar s0 plus s1 into s0 bar. So now here the s1 is connected to the p terminal, so this is p bar q plus p into q bar. So simply this is the expression for the XOR, so we are getting the XOR of p and q. So option D is correct. Okay, so now next question is, for the circuit shown, the count and state Q1 Q0 follows the sequence. So basically in this circuit 2 flip-flop are there and D flip-flop is there. So this is Q1 Q0, it means this Q1 is MSB and this is LSB. So now first of all we should know the characteristic equation of the D flip-flop. So for the D flip-flop, the characteristic equation is that the Q positive is equal to D. So now this is Q1 and Q0. Since no initial state is mentioned in the question, we will assume that it is initially at the 0 0. So now we have to find out the next state. So this is equal to Q1 positive. So now this Q1 positive, from the characteristic equation this will be equal to D1, and now here the D1 input is connected to Q0, so this will be equal to Q0. Similarly the next state for the Q0 positive is equal to D0 from the characteristic equation, and D0 input is connected to, so this is basically a NOR gate. Okay, so this is a NOR gate, okay, whose inputs are Q0 and Q1. So this is simply Q1 and Q0 bar. So this is a NOR gate. So now if the initial inputs are 0 0, then we will find the value of Q1 positive and Q0 positive, which are next state. Okay, so Q1 positive is equal to Q0. Here Q0 is 0, so this will be 0, and Q0 positive is the NOR of this. So 0 0 is 0, so its NOR will be 1. So now this will be our next state, so this will be 0 1. Now Q1 positive is Q0, so here Q0 value has now become 1. So now this is 0 1 NOR is 0. So now 1 0 is the next state. So now Q0 has become 0 and 1 0 NOR is 0. Okay, so now we can clearly see that the signal has started repeating. So first of all the sequence we have started with is 0 0. After that, after the first pulse is given, then 0 0 will become 0 1 after the first pulse. Okay, then 0 1 after the second pulse will become 1 0, and if again any pulse is given, then it will again go back to 0 0. So it means our sequence is 0 0 0 1 1 0 and 0 0. So this is matching with the option B. So now next question is, this is also a similar question, but now only the flip-flop has changed. Earlier we have used D flip-flop, now in this question we are using the JK flip-flop. So what are the counting states Q1 Q2 for the counter shown below? So this is MSB because this is written on the left hand side, and this will be LSB. So now first of all, let us know the characteristic equation of the JK flip-flop. So this is given by Q positive is equal to J Q bar plus K bar Q. So first we will obtain the characteristic equation for the first flip-flop. So Q1 positive will be simply J1 Q1 bar plus K1 bar and Q1. Okay, so now see here, the J1 input is connected to Q2 bar. Okay, so right here in place of J1 Q2 bar, because J1 is connected to the Q2 bar and Q1 bar will remain as it is, and K1 bar is connected to, so K1, okay, so K1 is connected to Q2 bar, so again bar will come, so it will become Q2 and this will become Q1. So it means we are getting the value of Q1 positive as, so this is the expression for the X nor, okay, so this can be written as X2 X nor Q1. Similarly we will obtain the expression for the Q0 positive. So Q0 positive is equal to J0 Q0 bar plus K0 bar and Q0. So now J0, so oh, this was Q2, okay, so this will be 2. So now J2 input is connected to Q1 bar, so this will be Q1 bar, this is Q2 bar plus, so here the K2 input is connected to 1, so 1 bar is 0 and this is Q2. So simply we are getting the value of K2 positive as Q1 bar and Q2 bar. So now we have obtained the expression. So now let's draw the table. So here we have the present state, okay, so this is present state and this will be next state. So this will be Q1 and Q2, and this will be Q1 positive we have obtained is Q2 X nor Q1, okay, and this will be Q2 positive expression we have obtained is Q1 bar and Q2 bar. Okay, so since no initial state is given, we will assume that it was initially at 0 0. So now 0 0 X nor is 1 and Q2 positive value will be Q1 bar, this is 1 into 1 is 1. So now next state will be 1 1. So 1 1 X nor is 1 and this will become 0. So next state is 1 0. So 1 0 X nor is 0 and this will become 0. So now the signal is repeating. First we have started from the 0 0, then after the first pulse it will go to 1 1, then after 1 1 it will go to 1 0, and then it will go to again back to 0 0. So it means our sequence is 0 0 1 1 1 0 0 0 and so on. So see here, this is matching with the option A. So we can either start from 1 1 also, okay, so we can start from here, this will be 1 1, then next pulse will give 1 0, then we will get 0 0, okay, so signal will repeat like this. So it means option A is the right answer. So thank you guys for watching this video. Please subscribe to the Techno Wizard YouTube channel.